If you've been running Apache Iceberg in production for any length of time, you've almost certainly hit the maintenance wall. It usually starts with a frantic message from your analytics team asking why the dashboard that took 5 seconds to load last week is now taking 2 minutes. The culprit is almost always the same: compaction. You see, Iceberg is amazing at tracking data, but it's passive. It lets you write thousands of tiny data files, but it won't clean them up unless you explicitly tell it to. You end up having to build and maintain separate Airflow DAGs just to run rewrite underscore data underscore files procedures, effectively becoming a janitor for your own data lake. The root of this issue lies in Iceberg's architecture, which treats files as relatively static snapshots. Whether you are doing copy on write or merge on read, every update creates new files. Iceberg doesn't have a background brain to merge these files automatically. It relies on an orchestrator like you or a managed service to trigger that cleanup. This works fine for batch processing where you load data once a day, but for streaming data where you have updates every second, it's a night. You end up fighting a losing battle against file proliferation, where your maintenance jobs consume more compute than your actual queries. This is exactly where Apache Paimon enters the chat. Paimon was built specifically because the community realized that standard lake formats were struggling with high throughput streaming updates. Unlike Iceberg, which acts more like a file list, Paimon behaves more like a database. It doesn't wait for you to schedule a cleanup script. It assumes that compaction is a critical part of the data lifecycle, not an afterthought. In Paimon, compaction isn't a maintenance task, it's a core feature of the writer itself. The magic behind Paimon's ability to handle this is its use of LSM trees, log structured merge trees, the same architecture used by high-speed databases like RocksDB and Cassandra. Instead of just dumping files into a folder, Paimon organizes data into levels. When data comes in, it lands in a memory buffer and is flushed to level 0. As soon as level 0 gets too full, Paimon automatically triggers a background merge to move that data to level 1 and so on. This means your data is being continuously optimized and compacted as it is being written, ensuring that your read performance stays stable without you ever writing a single line of maintenance code. So, what's the verdict for your data platform? If you are largely doing batch workloads or have a managed platform like Snowflake or AWS Glue handling the messy work for you, Iceberg is still the gold standard for compatibility. But if you are building a self-managed streaming data lake where you are ingesting CDC data from Maxwell or Kafka directly, you should seriously look at Paimon. It removes the compaction tax from your engineering team, letting you focus on the data pipelines rather than babysitting the file system.